If you're like me, you really love working in the Jupyter Lab environment, but you may miss the debugging features from your favorite IDE like PyCharm or VS Code. This week I'm going to show you how to use the Debugger extension in Jupyter Lab to get back some of that functionality. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week I want to show you the Debugger extension for the Jupyter Lab environment. I've already got some code written. I know we normally don't do that, but this week I want to really focus on using the debugger and less on writing some code. Right now the debugger only works with the Zeus Python kernel, or XPython, and you can install that by using the command conda install Zeus Python from the CondaForge channel. You can also change which kernel you're running by clicking on the kernel in the upper right corner of your notebook. You'll notice when you're running XPython, you get this debugger and little switch up here, which is a big hint as to what we're going to do. But first, let's look at my code. We don't normally run our code with the debugger turned on. It does slow things down some. So I've got some imports, like we always do. A function that calculates the mean of some values, it looks like. A function that fits a line, judging from the looks of it, some kind of a sum of squares of errors type thing. Okay. And then I've got some x data and y data that I plot. This looks like a nice simple line. We want to make sure that our line fitter works. That looks suspicious. I don't know that I expect a slope of 25 from this or an intercept of minus 56. In fact, it's always important to know what you expect to happen from a piece of code before you run it. We know here the slope should be 1 and the intercept should be 0. I'm going to confirm that by running polyfit from NumPy, and yes, the slope is 1, the intercept is 0. Just to be sure it's not something weird about a 0 intercept in my code, I'm going to try some other data. Maybe it's not a perfect fit. And indeed, these don't match. There's no great clue. Nothing's off by a factor of 10. It's sort of close there. Maybe that'd make me suspicious at first, but it's not. Okay, so we've got a problem. And how are we going to find this problem? Well, we could start putting a bunch of print statements. Maybe it's calculate mean. Is that something that's wrong? So we could put in here print mean of x. Now we go run our data. Okay, that's 2.5. Does that make sense? Yes, 2.5 is the mean. Okay, I can remove that. I could go down here. Print mean of y, 2.5, okay, that makes sense. And you could keep doing this, but that can get cumbersome. And if you get too many print statements, often, well, one, you forget to remove them, and they clutter up the output of your script, or you don't know which print statement goes with what, and it's actually more confusing than it is help. So this is where debuggers step in. They're really the right tool for tackling problems like this. Also, if the problem is in some other chunk of code, it's easy to step into and step through that with a debugger. Now, I will say the debugger for the notebook is not as full-featured as some IDEs, but it is not bad, especially when you're just hacking together some code in a notebook, and it would be really handy to see what the value of a few variables are. All right, so let's turn on the debugger. We hit that switch, and we get this handy little panel that pops up. You'll also notice that line numbers were toggled in each cell, and if we hover in the left column, we get a red dot that lets us set a breakpoint. So let's go ahead, run some code. Okay, fit line. Okay, so this is where things are not working. I'm going to go up here into my fit line function. First off, I know the slope is wrong. So let's do some inspection on the slope. So I'm going to stop. I'm going to set a breakpoint here. So it's going to run up to but not executing this line of code. And let's run our fitLine function. All right. Up here we can change our view of variables. I don't like the expandable view. For example, I have to expand in here. I don't find that as useful most of the time, but the list or the tabular view is quite nice. So there's my mean x and mean y, my slope. See, I didn't have to do any print statements to get all of this information. And my program execution is just paused right there. So now what do I want to do? I've got a few options. I can continue, which means go past the breakpoint, keep running until we finish the cell that called this. I can stop, which is a halt. Next means go on to the next line of code. Step in and step out we'll get to here in a little bit. If you've used debuggers before, you're probably already familiar with how they work though. Okay, so our slope is 5. So we're going to keep that in mind. I know the slope should be 1. And right now I've effectively calculated part of it. So I would expect this part to come out to 1/5 if I want my final result to be 1. So we're going to go to the next. No, it's 25. So there's something wrong in one of these 2 lines of code that calculates my slope. I know what I should do. I should probably look at the formula for slope and do some hand calculation or get a calculator and work a simple example and see what I get versus what I'm getting in my script. Intercept is fine. We don't need to keep running. We could keep clicking the next, or I can just go ahead and click the play symbol. Okay, so now we've got a little bit of an idea. I'm going to unset that breakpoint and let's go in and take a closer look. Well, I know that the sum of squares of errors, okay, so I'm getting an error, x minus mean x, y minus mean y. I'm multiplying those together. Okay, that looks fine. X minus mean x squared. Okay, I know that this should actually have been a divided by. This is the numerator of my slope equation. This is the denominator. Okay, so let's try running these cells again. Okay, my slope is right, but my intercept is wrong. Let's try it on the second data set as well. Okay, my slope is right, but my intercept is wrong. It's wrong differently now, though, because the intercept, of course, depends on what we calculate as the slope. Well, as it turns out here, I'm a little parentheses happy. This has happened many times. If I remove those, now I'm matching exactly. Now, I will grant you this is a pretty simple set of some typos and math errors that are very basic, but it shows you how a debugger can help you step through a problem. Because if this were even more complex with slope or intercept being manipulated more times, it's really nice to be able to go through line by line and look at those variables. How many of us have put print statements like this? Print slope. And then down here, print slope. To get some information like this. The debugger doesn't require you to alter your code. It's faster to use. It doesn't leave messy outputs. And it shows you all the variables, not just the ones that you're printing. Now let's look at one more set of features here. Let's say that this fit line is one call in many calls in some more complex data processing function. And I set a breakpoint there. I'm going to go ahead and run my code. Okay, so I've stopped. I haven't executed fit line yet, but I'm about to. If there were another line after it, say another data processing line or some kind of print or graph, if I click continue, we're going to go on to that. What I want to do instead is click step in. So step in takes me into the function that we're calling. Now I can go line by line, not setting any breakpoints in my function, just setting them in my larger script, let's say. So I can set one breakpoint. I know before here it works. I know after here it doesn't. I can step through those, and when I find the step that's suspicious, I can do it again and step into that. So now I'm going through here. Okay, everything looks good. I've decided that this function is okay. I don't need to inspect it anymore. I want to get back out and go on with my main script. That's where we use the step out. Now we've got our output printed, and we're moving along as I go to next. Or we can just continue our program. I hope that you found this useful. The debugging extension, like I said, though it's not quite as mature as some other more advanced debuggers, it is very easy to use, and if you're stuck on a problem in a notebook, I encourage you to check it out. I hope that you found this useful, and I'll see you on next week's MetPy Monday.